Good day everyone, my name is Doric Jubilea H. Martin from BSC 3H and my report is all about evaluating transportation alternatives. First, let's define evaluation. It is a fact-finding process in which all outcomes are reported separately in a matrix format. Through evaluation, the decision maker obtains complete information about a certain project's outcome. Post-facto evaluation is described and illustrated using the results of evaluation for completed project. Basic issues in evaluation. First is the objectives of evaluation. Dito nakasaad yung mga informations na kailangan sa pagsasagawa ng isang project. The objective of an evaluation is to furnish appropriate informations about the outcome of each alternative so that a selection can be made. Halimbawa nito, there is a need to improve safety at a certain railroad crossing dahil maraming aksidente ang naitatala sa lugar. May iba't ibang alternatives na maaaring gamitin. Pwedeng mag-install ng mas maraming lights, signs, o pwede din namang magtayo ng overpass. Sa dalawang alternatives na nabanggit, magkaiba yung magiging cost nila in terms of money. Pero iisa lang yung magiging resulta. Next is identifying project stakeholders. Sa paggawa ng daan, maliit man o malaki yung sakop nito, may mga tao pa din na maaapektuhan. Ito yung tinatawag na stakeholders kung saan pinapahalagahan yung views and opinions nila dahil kadalasan yung mga stakeholders sila yung mga taong nakatira malapit sa site or sa mismong site at yung mga gumagamit ng kalsada, yung mga motorista, at yung gagawa ng project o yung workers o yung engineer. Next is selecting and measuring evaluation criteria. Criteria selection is a basic element of evaluation process dahil ito yung nagsisilbing basihan kung alin sa mga alternatives o solution ang mas karapat-dapat na gamitin. Next is yung measures of effectiveness. Sa pag-measure ng effectiveness ng isang solution or alternative, may tatlong way na kadalasang ginagamit. Una doon ay ang pag-convert sa numerical value. Dito sa approach na to, ginagamit ang scores. Nagbibigay ng corresponding points at kung alin sa mga alternatives o sa mga solution na yon ang mayroong highest score, yun ang pipiliin. Next naman ay ang pagko-convert ng effectiveness sa isang common unit. Dito pumapasok yung economic point of view dahil maaaring pagsama-samahin yung mga gastos or cost ng isang solution at kung alin yung mas cost-effective, yun yung pipiliin. Last naman ay ang paggamit ng matrix form. This approach furnishes the maximum amount of information without prejudging either how the measures of effectiveness should be combined or their relative importance. Next is the evaluation, procedures, and decision-making. The decision maker must thoroughly know and review all the alternatives present at the situation and decide on what solution should be implemented. There are two types of evaluation. First is yung evaluation based on economic criteria and yung evaluation based on multiple criteria. Sa evaluation of based on economic criteria, mayroong elements of cost. First cost, continuing cost, sunk cost, at road user cost. Sa first cost, it basically means construction cost. Yun, sa continuing cost naman, dito nakapaloob yung maintenance cost, and operation cost. Sa sunk cost, hindi nagbabago to kahit na anong solution or alternative yung piliin. At ang example ng sunk cost ay ang administration expenses at other overhead charges. Sa road user cost, kadalasan tinatawag siyang benefits. At nahati siya sa tatlo. Una ay ang motor vehicle running cost, traffic accident cost, at value of travel time. Sa motor vehicle running cost, naapektuhan siya ng driver's behavior, vehicle factors like fuel, engine oil, tires, maintenance, and depreciation of vehicle. At naapektuhan din siya ng highway and traffic factors kagaya ng distance, vertical grades, horizontal curvature, roadway surface, speed limit, at traffic control devices. Samantalang yung traffic accident cost at yung value of travel time, naapektuhan lang siya ng driver's behavior at highway and traffic factors. Sa pagko-compute ng time travel cost, may formula na sinusundan. Time travel cost is equal to 1,000 divided by AES or yung average effective speed of vehicle type multiplied by the average value of 1 hour of travel time for occupants and cargo in vehicle type. Present worth, it represents the current value of all the cost that will be incurred over the lifetime of the project. Sa pag-compute nito, meron din tayong formula. PW or present worth is equal to the summation of C sub n over 1 plus I raised to n, where C sub n stands for facility and user cost incurred in year n. And n naman is the service life of the facility, and I is the rate of interest. Net present worth. The net present worth of a given cash flow that has both receipts and disbursements. Net present worth is equal to the summation of R sub n over 1 plus I raised to n plus S over 1 plus I raised to n minus the summation of M sub n plus O sub n plus U sub n all over 1 plus I raised to n minus C sub O, where C sub O is the initial construction cost, N is the specific year, M sub n is the maintenance cost, O sub n is the operating cost, and U sub n is the user cost. S is the salvage value, R sub n stands for revenues, and N stands for the service life. Equivalent uniform annual worth, or the conversion of a given cash flow to a series of equal annual amounts. Sa pag-compute nito, may formula na ginagamit. EUAW is equal to the net present worth multiplied by I multiplied by 1 plus I raised to n all over 1 plus I raised to n minus 1. Benefit cost ratio. It is the ratio of the present worth of a project benefits and net project cost. Sa pag-compute nito, may formula din na ginagamit. BCR is equal to B over C, where B is the reduction in user and operation cost between the higher cost alternative 2 and lower cost alternative 1, and C stands for increase in facility cost. Rating and ranking. Ito na yung sa evaluation based on multiple criteria. Dito ginagamit yung numerical scores na nabanggit ko na kanina. At sa pagsasolve nito, may formula na ginagamit. S sub I is equal to the summation of K sub J multiplied by V sub I sub J. S sub I stands for the total value of score of alternative I, and K sub J is the weight placed on criteria J, and V sub ij is the relative value achieved by criteria J for alternative I. Cost effectiveness. This approach uses data from economic analysis and at the same time permits other intangible effects such as environmental effects. Evaluation as a fact-finding process. Ito yung technique na ginagamit para mas ma-examine ang iba't ibang alternatives or solution. May 4 na activity na ginagawa dito. First is yung activity 1. View issues from the perspective of each affected interest. Activity 2. View issues from perspective of each action. And activity 3. View issues from perspective of process as a whole. And activity 4, prepare summary evaluation report. Trade-off and balance sheet analysis. These approaches display the impacts of plan alternatives to various groups. Next, evaluating effects of transportation on social and natural systems. May 4 na step na ginagamit dito. Step 1, assess the need for the project. Kung kailangan ba talaga yung project na yon. Step 2, conduct a feasibility analysis of the alternatives. Step 3, analyze the impact of the project from the following points of view: transportation system effects, social and economic effects, and natural system effects. At sa panghuling step, Step 4, organize the results of the evaluation so that the stakeholders can understand it. That would be all. Thank you.
Good day everyone, my name is John Patrick Garcia from BSCE3H and I am going to discuss forecasting travel demand under transportation planning. Forecasting travel demand. Travel demand is expressed as the number of persons or vehicles per unit time that can be expected to travel on a given segment of a transportation system under a set of given land use, socio-economic, and environmental conditions. Demand forecasting approaches. There are two basic demand forecasting situations in transportation planning. The first involves travel demand studies for urban areas, and the second deals with intercity travel demand. Factors influencing travel demand. The three factors that influence the demand for urban travel are: number 1, the location and intensity of land use. Number 2, the socio-economic characteristics of people living in the area. Number 3, the extent, cost, and quality of available transportation services. These factors are incorporated in most travel forecasting procedures. The next one is sequential steps for travel forecasting. Travel forecasting is solely within the domain of the transportation planner and is an integral part of site development and traffic engineering studies as well as area-wide transportation planning. The approach most commonly used to forecast travel demand is based on the land use and travel characteristics that provide the basis for four-step process of trip generation, trip distribution, modal choice, and traffic assignment. Trip generation. Trip generation is the process of determining the number of trips that will begin or end in each traffic analysis zone within a study area. Since the trips are determined without regard to destination, they are referred to as trip ends. Each trip has two ends, and these are described in terms of trip purpose or whether the trips are either produced by a traffic zone or attracted to a traffic zone. Under trip generation, we have cross classification. It is a technique developed by the Federal Highway Administration or FHWA to determine the number of trips that begins or end at home. Home-based trip generation is a useful value because it can represent a significant proportion of all trips. We also have rates based on activity units. The preceding section illustrated how trip generation is determined for residential zones where the basic unit is the household. Trips generated at the household ends are referred to as productions, and they are attracted to zones for purposes such as work, shopping, visiting friends, and medical trips. Another one is balancing trip reductions and attractions. A likely result of the trip generation process is that the number of trip reductions may not be equal to the number of trip attractions. Trip reductions, which are based on census data, are considered to be more accurate than trip attractions. Trip distribution. It is a process by which the trips generated in one zone are allocated to other zones in the study area. These trips may be within the area, are internal to internal, or between the study area and areas outside the study area, internal to external. Under trip distribution, we have gravity model. The most widely used and documented trip distribution model is the gravity model, which states that the number of trips between two zones is directly proportional to the number of trip attractions generated by the zone of destination and inversely proportional to a function of time of travel between the two zones. Next, we have growth factor models. Trip distribution can also be computed when the only data available is the origins and destinations between each zones for the current or base year and the trip generation values for each zones for the future year. Mode choice. Mode choice is that aspect of the demand analysis process that determines the number or percentage of trips between zones that are made by automobile and by transit. Types of mode choice models. Depending on the level of detail required, three types of transit estimating procedures are used. Number 1. Direct generated of transit trips. Number 2. Use of trips and modals. Number 3. Trip interchange modal split modals. Direct generation models. Transit trips can be generated directly by estimating either total person trips or auto driver trips. Next is trip ends model. It is used to determine the percentage of total person or auto trips that will use transit. Estimates are made prior to the trip distribution phase based on land use or socioeconomic. And lastly, trip interchange model. In this method, system level of service variables are considered, including relative travel time, relative travel cost, economic status of the trip maker, and relative travel service. Under mode choice, we also have logit models. An alternative approach used in transportation demand analysis is to consider the relative utility of each mode as a summation of each modal attribute. And lastly, we have traffic assignment. The final step in the transportation forecasting process is to determine the actual street and highway routes that will be used and the number of automobiles and buses that can be expected on each highway segment. Under traffic assignment, we have basic approaches. Three basic approaches can be used for traffic assignment purposes. Number 1 is the diversion curves. Number 2 is minimum time path, all or nothing assignment, and number 3 is minimum time path with capacity restraint. Diversion curves. This method is similar in approach to a mode choice curve. The traffic between two routes is determined as the function of relative travel time or cost. Next is minimum path algorithm. The traffic assignment process is illustrated using the minimum path algorithm. This method is selected because it is commonly used, generally procedures accurate results, and adequately demonstrates the basic principles involved. And lastly, capacity restraint. A modification of the process just described is known as capacity restraint. The number of trips assigned to each link is compared with the capacity of the link to determine the extent to which link travel times have been increased by the additional volume placed on the formerly empty link.
Good day everyone, my name is Rexel Faith Fernandez and this is the continuation of John Patrick Garcia's report, Forecasting Travel Demand. Other methods for forecasting demand. This chapter has described how travel demand is forecast by using the four-step procedure of trip generation, distribution, mode choice, and traffic assignment. There are many variations within each of these steps, and there are other methods that can be used to forecast demand. Some of these are described in the following section. Trend analysis. This approach to demand estimation is based on the extrapolation of past trends. For example, to forecast the amount of traffic on a rural road, traffic count data from previous years are plotted versus time. Then to compute the volume of traffic at some future date, the trend line is extrapolated forward, or else the average growth rate is used. Demand elasticity. Travel demand can also be determined if the relation between demand and a key service variable such as travel cost or travel time is known. We have here the formula for demand elasticity. In addition to linear formula, there are two arc elasticity, the midpoint and log arc elasticity, where D sub O is the original demand level and the D sub N is the new demand level, while X sub O is the original service level and X sub N is the new service level. Estimating freight demand. This section discusses procedures available for estimating freight traffic. Estimating freight demand has two procedures for estimating freight traffic. The first one is using trend analysis of freight vehicle travel. With this procedure, this is based on vehicle flows. Freight flows may be computed using the trend analysis of traffic flow that forecasts freight movements by truck and rail, or may be determined directly from observation of prior goods movement activity. We have here the formula B sub x is equal to B sub O multiplied by 1 plus I raised to n. And here is the second method, which is using commodity flow data to forecast freight vehicle travel. This conversion must be based on the payload for each mode, which will vary by commodity, the extent to which there are empty or return trips, and the number of days per year that the mode will be operable. A more productive approach for estimating freight travel is to base forecasts on commodity travel. Once commodity flows are estimated, they can be converted to vehicle flows. Travel impact studies. The purpose of a travel impact study or a transportation impact analysis is to determine the impact on traffic and the need of transportation services in the immediate vicinity of a proposed development or as the result of a change in zoning designation. Impact studies are conducted for a variety of reasons. These include: number 1, to determine whether a landowner should be granted permission to develop a given parcel of land that may require rezoning from its current designated use to the use proposed by the developer. Example of these are from agriculture to commercial. Number 2, to permit a landowner to subdivide the property into 2 or more parcels. 3, to obtain a building permit. 4, to grant direct access from a development to the transportation network. Number 5, to evaluate the effects of a country-initiated zoning plan. And last but not the least is to create a special use tax district. Data requirements for a traffic impact study. There are 3 levels of data collection. Number 1 is the low effort level data. This data can be obtained within a minimal time investment, while the medium effort level data require more time to obtain but can give more precise predictions. On the other hand, high effort level data are quite time consuming to obtain and are often only available when a specific development proposal are being considered.
So, good day everyone. Today, we're going to discuss the topic about transportation planning. So, first is, what is transportation planning and how does it work? Transportation planning is the process of evaluating the current state of transportation in an area, planning for potential transportation needs, and integrating budgets, priorities, and policies into the mix. It analyzes everything from streets and highways to freight ships, public transportation, and bike lanes to help shape how a neighborhood or city develops. Anything from industry to leisure to quality of life is influenced by it. It is also the methodological process of preparing physical facilities and services of modes for transportation needs. It is not intended to furnish a decision or to give a single result that must be followed, although it can do so in relatively simple situations. It is intended to provide the appropriate information to those who will be affected and those responsible for deciding whether the transportation project should go forward. So next is the basic elements of transportation planning. The transportation planning process comprises 7 basic elements. Number 1 is the situation definition. Number 2 is the problem definition. Number 3 is the search for solutions. Number 4 is analysis of performance. Number 5 is evaluation of alternatives. Number 6 is choice of project. And number 7 is specification and construction. So, when we say basic elements of transportation planning, the elements are interrelated, not necessarily carried out sequentially, and the information acquired in one phase of the process may be helpful in some earlier or later phase. So, there is a continuity of effort that should eventually result in a decision. So, number 1 is the situation definition. Involves all of the activities required to understand the situation that gave rise to the perceived need for a transportation improvement. The present system is analyzed and its characteristics are described. Information about the surrounding area, its people, and their travel habits may be obtained. Previous reports and studies that may be relevant to the present situation are reviewed. So, the situation definition also inventory the transportation facilities, measure travel patterns, and review prior studies. Next is the problem definition. To describe the problem in terms of the objectives to be accomplished by the project. To translate those objectives into criteria that can be used to quantify the extent to which a proposed transportation project will achieve the stated objective. It also identified the characteristics of an acceptable system, constraints placed on the project, and design standards. It is also defined objectives, established criteria, and established design standards. Next is the search for solutions. Consideration is given to a variety of ideas, designs, location, and system configurations that might provide solutions to the problem. It also includes preliminary feasibility studies, which might narrow the range of choices to those that appear most promising. Some data gathering, field testing, and cost estimating may be necessary at this stage to determine the practically and financial feasibility of the alternatives being processed. It also considered options, example, location and types, structure needs, environmental considerations. So next is the analysis of performance. To estimate performance of proposed alternatives under present and future conditions. It is the determination of the investment cost of building the transportation project as well as annual costs for maintenance and operation. It involves the use of mathematical models for estimating travel demand, determine use of the system such as trip length, travel by time of date, and vehicle occupancy, and also environmental effects are estimated. It also, for each option, determine costs, traffic flow, and impacts. So, next is the evaluation of alternatives. How well each alternative will achieve the objectives of the project as defined by the criteria. Performance data produced in the analysis phase are used to compute the benefits and costs that will result if the project is selected. It is also determine the values for the criteria set for evaluation. So, example is the benefits versus cost and cost effectiveness. So, next is the choice of project. It is made after considering all the factors involved. Whether the factors were a single criterion such as cost, select the lower cost. In more complex projects, other factors may be considered selection is based on how the results are perceived by those involved in decision making. It is also considered the factors involved, example, the goal attainability, political judgment, and environmental impact. So last is the specification and construction. It is a detailed design phase in which each of the components of the facility is specified. This involves its physical location, geometric dimensions, and structural configurations. Once an alternative is chosen, design necessary elements of the facility and create construction plans.
So, transportation planning institutions. This transportation planning process is based on a systems approach to problem solving and is quite general in its structure. The process is not confined to highways but can be applied to many other situations such as intercity high-speed rail, feasibility studies, airport location, port and harbor development, and urban transportation system. So this transportation planning institution is most commonly applied in urban areas, where it has been mandated by the law since 1962 that when Federal Aid Highway Act required that all transportation projects in urbanized areas with population of 50,000 or more must be based on a transportation planning process. Next, we have the Transportation Planning Organization. So in carrying out the urban transportation planning process, we have several committees that represents various community interests and viewpoints. So first we have the policy committee. So the policy committee is composed of elected or appointed officials such as the mayor or director of public works. So they represent the governing bodies or agencies that will be affected by the results. Next, we have the technical committee. So the technical committee is composed of engineering and planning staffs that are responsible for carrying out the work or evaluating the technical aspects of the project that is prepared by the consultants. Next, we have the Citizens Advisory Committee. So in Citizens Advisory Committee, it is composed of a cross-section of the community and may include representatives from labor, business, interested citizens, and members of community and interest groups. So the committee's function is to express the community goals and objectives and to suggest alternatives and also to react to propose alternatives. Next, we have the Metropolitan Planning Organization or the MPO. So it is a transportation policy making organization that is made up of representatives from local government and transportation authorities. Urban transportation planning. So urban transportation planning involves the evaluation and selection of highway or transit facilities to serve present and future land uses. So it is concerned with two separate time horizons. So the first is a short-term emphasis intended to select projects that can be implemented within a 1 to 3 year period. So these projects are designed to provide better management of existing facilities by making them as efficient as possible. So the second time horizon naman deals with the long-range transportation needs of an area and identifies a project to be constructed over a 20-year period. So, urban transportation planning is a planning process that has been enhanced through the efforts of the Federal Highway Administration and the Federal Transit Administration of the U.S. Department of Transportation by the preparation of manuals and computer programs that assist in organizing data and forecasting travel flows. So, in short-term projects, it involves programs such as traffic signal, timing to improve flow, car and van pooling to reduce the congestion. So, park and ride fringe parking lots to increase transit ridership and transit improvements. So, yung long-term projects naman, it involves programs such as adding new highway elements, additional bus lines or freeway lanes, rapid transit systems and extensions, or access roads to airports or shopping malls. Next, we have the forecasting travel. So, travel demand forecasting is an essential part of a transportation engineer's skill set. So, it enables the engineer to forecast the amount of traffic that will use a particular transportation feature in the future, whether it is a current highway or proposed light rail line. So, to accomplish the objectives and tasks of the urban transportation planning process, a technical effort referred to as the urban transportation forecasting process is carried out to analyze the performance of various alternatives. So, we have four basic elements and related tasks in the process. First, you have the data collection or the inventories, analysis of existing conditions and calibration of forecasting techniques, forecast of future travel demand, and analysis of the future results or the analysis of the results.